to be connected to. How about now? There we go. So transport layer security, TLS is an old protocol. It's ubiquitous. It's all over the internet. Basically, everything supports it. If you're not using it, you probably should be. And the important thing is that, yeah, all websites already support it. And so, yeah, basically, it's a protocol between your computer and a website that you're connecting to. It's using cryptography. So you can query data from a website and know that you're talking to the website you expect, and your communications are protected. But one thing that it can't do for you is you can't query data from a website and then present it to another party. There's reasons for this that I won't really go into, but you can just know safely that it's not possible to just take a TLS transcript and send it to someone else. They won't know whether or not the data is actually authentic. But TLS, there are signatures there, there's cryptography there, and maybe we can plug into it and somehow leverage it for what we want to do, which is to allow people to privately prove data to a third party. I'm not sure if you've come across this jargon before. There's multiple different terms, multiple different approaches for generally the same thing. MPC TLS, ZK TLS, web proofs, TLS middle boxes, witness proxy. They're all essentially trying to do the same thing. We've implemented MPC TLS, and this leverages multi-party computation and zero-knowledge proofs in order to allow a prover to privately disclose data to a verifier in a malicious secure way. And then there's other approaches, like a proxy approach, which kind of switches up the topology here, which puts the verifier in between the prover and the website. But, oh, right. One thing to note here is that both these approaches, both the MPC TLS approach and the ZK TLS proxy mode, whatever you want to call it, these are both designated verifier protocols, which means that it's really between two parties, and the only party who really receives cryptographic assurances is the verifier that's actually running the protocol itself. Sorry for everyone that wants to do things on-chain. This does not give you trustless oracles, but it does give you a trustless off-chain designated verifier protocol. And yeah, all approaches kind of all go towards the same affordances, which is that it allows you to basically compose with any application. If there is data on the internet, which is queryable using TLS, you can trustlessly compose with it and without asking for permission. So all servers are already running TLS. So you can basically take our protocol, wire it into your application, and now users can just prove arbitrary data to you in a privacy-preserving manner. And just to elaborate on the privacy part there, user can query data from some arbitrary data source and present it to your application while redacting their secrets, such as their cookies and their HTTP request. They can redact data in the response. And we're probably not going to get into it today, but you can also do zero-knowledge proofs over the top of that data, such as hiding your address but proving you're not in the United States, and then the classic example of proving that you're above some age without revealing your exact birth date. Yeah, so those are the general affordances that these protocols provide. TLSNotary is free, open source. The core protocol is written in Rust. We have TypeScript bindings. We're going to demo a browser extension / plugin system, which is just one way of distributing the TLSNotary protocol. And yeah, it's Apache, MIT, dual licensed at your option. Do whatever you want with it. Yeah, so that's an introduction to generally what TLSNotary is and what it does. And yeah, let's just hop straight into building something.
So good afternoon. I'm Hendrik, also from the TLSNotary team. And this is our schedule for the workshop today. We are plenty of members of the TLSNotary team, so if you have questions, there's Tanner, Ryan, who else do I see? Thomas in the back, Chris, and then Tsukino and Sinu. So just if you run into any questions, just ask. So we just had this great introduction to TLSNotary. We'll start with coding part 1. So that will be mainly on your own machine, everything offline, so that we don't run into any network problems. Then we'll do some experiments with TLSNotary where you work together with your neighbor. So just distribute the roles. And then we switch to the browser extension, where we'll do a demo first, and then Tsukino will give an overview of how all browser setup works. Then we'll switch to coding part 2, where we'll build our own plugins, and then we'll do a short, an extra slide with some where we go into the future of TLSNotary and discuss what comes up next. And then there's some playtime where we invite you to build your own plugins or build on top of TLSNotary, and we're here to help you. And then we also very open to hear all your questions. So some tips and tricks for the workshop. So don't rush through all the items. We have time. There is a HackMD document. It allows for adding comments. So if you run into any into things that don't make sense, or you see typos or whatever, just comment so that we can improve it for next time. Also check the Wi-Fi. So there is a local Wi-Fi network here that allows us to connect to each other. So make sure you're on the I can't read the name, but I think it's a classroom network. The network, the password is also over there. Also for the web devs that will do a little bit of Rust, but it's only reading Rust code, so don't be intimidated, that you should be fine. And also, as I said, the TLSNotary team is here, so if you have questions, just ask them. So if you go to this URL, you will find the classroom notes. And yeah, if you have any issues, just call us and then we will help. So maybe a quick overview of what we will do there. So we will start with the most basic setup of TLSNotary, where we just have a server, a prover, and a verifier, where everything is on the same networks on your local computer. So we'll start with starting all the necessary services. And then the prover will do the request to the web server with the cooperation of the verifier. This will return in an attestation. We will then create a presentation where we redact some information, and then the verifier will verify the info. And then the second part, we will work with a neutral notary, so where the roles of the verifying parts are split up. So this is all in Rust. And then in the third part of the example, we will run the prover in the browser. And then in the notes, you will see that then we will also distribute the roles. So you could run the prover, and your neighbor could be the test server, and another neighbor could be the verifier. Should be fun. Any questions so far? Yeah. The first one is the TLSN repository. So the question was which repository for the first item. So that's the TLSN repository. Sorry, so if you didn't bring your laptop, this will be a very boring workshop, I'm afraid. So maybe then just chat with some of us and ask us your questions. If you have an error message running the last command, don't stress, that's for further in the workshop. So the prerequisites is mainly to have all the dependencies on your laptop so that you can go through the following steps. If you run into a Rust C error, check your Rust compiler version and then just do rust update to get the latest Rust compiler.
they couldn't install the PDK.
So how are we doing? Did everybody get through the solo tasks? Are there already teams doing notarizations? Maybe hands, like one hand is solo, two hands is teams? Okay, I'll give you more time.
Real quick, if you run into anyone with so we had a few people, 3 so far only, that have had issues with XSMJS.
Yeah.
And we couldn't figure out what it was.
Well, so XSMJS is not installed.
We're being rate limited.
Ah.
They can't run the install script.
Okay.
So they're having to build it from scratch or just a VPN on.
Okay, well, we'll do that tsukino when he's...
Yeah.
Yeah.
But yeah, me and Tsukino just spent like the last 20 minutes trying to figure out why it wasn't.
Okay. Yeah.
Because yeah, it was like, why is it everyone else is fine, but then like 3 people.
Yeah. I thought it was something missing in our scripts.
No, something in the
okay.
X's and something in the,
Yeah,
there's
yeah.
like the first line of the install script is an API call. And it's being rate limited.
Yeah. Yeah. Can I have your attention for a second? So we made a mistake in the notes. So if you get to testing the browser extension, you do get an error message in the notary, because so far for the Rust examples, we were on the dev branch, but the browser extension is still on the stable version. So before you run the browser extension, switch to the Alpha 7 branch in the TLSN repository, and then restart the notary. But in Alpha 8, we added this feature where you can disable TLS from the command line. In 8, so in the dev version, that is possible, but on 7, not. So you need to edit the config file. So go to notary server config.yaml, and so set this line to false before you start the notary. Okay. Yeah. We're getting a little bit behind schedule, so I'll give you 5 more minutes, and then we will switch to demo mode, and then I will show the Connect API, and then we'll do the Tsukinos part. So to save some time, I will show you what the web app demo looks like, and then afterwards Tsukino will show you how it actually works in the internals. So we have built this demo app for TLSNotary, where we built this app where we ask a user to prove that he has a Twitter profile. Then our backend checks that attestation, and then in the end we reward the visitor with a POAP. So if you didn't go through it yet, you can do it later and earn your POAP. So this app first invites you to install the extension, but I already have it on my computer. Next step is to install a plugin to the extension to connect to the actual Twitter demo. Of course, we don't want to just install random plugins, so we always ask the user, do you agree with installing this into the TLSNotary extension? And so this also gives an indication of what the plugin will do. So it shows you that it will run requests to the proxy, access api.x.com, and then it will do requests to this URL. So there's nothing strange going on behind the scenes. And then, of course, it also needs to query some more information. Now the plugin is installed. When you do run plugin, again, you need permission to do it. And when you click it, you go through the steps. But I think most of you already went through these steps. If we switch back to this demo app, then now the app is also listening to whether the attestation is ready. So once the attestation is available, the backend will then verify the proof, and then as a reward, you can claim the POAP. But Tsukino, do you explain what was actually going on here?
Hi, good afternoon. So you already saw a demo of the browser extension and plugins. To kind of give a brief overview of the extension, what it is it basically caches all the headers and all the cookies from your browsing history, and then on request, it will provide that to the plugin and create these notarizations. So you guys saw the demo, and we created a Connect API for the browser extensions. You can check out the documentations. But on a very high level, it is the equivalent of the window.ethereum object, but for TLSNotary. So similar to how MetaMask and other extension, wallet extension, inject a provider to window, we also insert a provider to window.TLSN, and from there you can use that to interact with the extensions and do stuff. So it's pretty simple to use it. I'm gonna walk through a few use case. When your app first load, you can listen to an event called TLSN loaded, and then once it's ready, window.TLSN will be ready, and you can grab that. You can then call the connect function. It will pop up a permission window, approval window, asking for permission to connect to this website. And once connected, basically they will be able to request for notarizations and ask for notarization history and stuff like that. After that, this is, if you, let's say if you want to create a attestation for some website, in this case I'm using swappy.dev as an example. You can do it with the client object that you just created by connecting to the extensions. Very similar to how you make a fetch request with some extra metadata. You can create an attestation for this API. And once you create the attestation, you can also use get history to get like the attestation that you just created. So all these method is designed to help app developer to easily interact with the extension, to create proof, verify proof, and be able to do stuff that you need to do in your app. So we also develop a plugin system that allow you to create a plugin to prove whatever web data you want. When you prove a web data from a web API, usually the flow goes like, give me cookies of this website and give me headers of this website. I will then use that information to piece together the request parameter, and then I will submit this request parameter to the notary or to the interactive verifier, and then start the notarization process. So all these steps are, you're able to do all these steps in the plugin systems with the API that we provided. I'm going to go through really quickly what the API looks like. You can also go to the documentation site down below. We have a boilerplate repository that you can check out to see how plugins are written. A lot of you already have already checked it out. The plugin center around this like config.json object. The main idea is we don't want to just inject all cookies to any plugin or headers to any plugin. So you have to ask specifically for permissions. In this case, the plugin is requesting for all cookies from api.x.com, all headers from api.x.com. We also enforce what host function you're asking for, or you need permission for. Right now, we only have two host functions, one to redirect the current browsing tab, and the other to send a notary request. At some point, we'll probably have more. And then the fourth permission here is the type of request that a plugin can make. Basically, we don't want the plugin to be able to send any request to any host, like they could just send your cookie to some host. That's why we put this enforcement here. The plugin will only be able to send a GET request to api.x.com/blah, blah, blah. And after that, you describe in the config what your plugin does. Title, description, those are metadata. The steps array here describe how many steps this plugin will have and what each step does. The action there corresponds to a function name that you create in the plugin code. So for example, the first step is called start. And here is a very simple start method. Basically, it checks to see if you're on x.com. If not, redirect to x.com. And then the second step is basically getting cookies from x.com, getting all the headers, making sure you have the required cookies and headers, and then piece together the parameters that you need to make the notary request. And the final step here is sending it to the notary to make a notarization request. There is another method that is referenced here called get secret response. Basically, what that does is, if you don't want to reveal everything to the notary, you can call this. You can create this method to selectively disclose what you want to disclose to a notary. In this case, I am only disclosing my Twitter screen name to the notary and nothing else. No cookies, no headers. This will pause the response and make sure that it's only revealing what I want. And once that happens, this is what the plugin step UI look like. In the future, we'll add more API to allow more customization on the UI level. But for now, if you describe what your steps look like, it will be rendered in this manner, go through step by step, and then at the end, create the notarization. I think, Oh, yeah. And if you are trying to compile or build a plugin, you might have already run into this issue where xsystem.js is not found. We forgot to put that in the documentation, but basically xsystem is what we use to build the plugin system. And in order to install xsystem.js, you basically you just go to xsystem/js-pdk, not SDK, PDK, and then run the install script there. After that, you have xsystem.js and be able to build scripts. Cool. Anyone have questions?
So compiling the plugins shouldn't take long, and then we switch to the part with what's coming up next for TLSNotary.
Okay, if we're gonna kind of speed through the plugin part here, yeah, let's just talk about what's next for TLSNotary. So Alpha 8 coming soon. I'm surprised that not more people asked me when Quicksilver and when Opticode. They're coming. So Quicksilver certainly in Alpha 8, Opticode, that depends. Quicksilver is of higher priority. It's essentially performance improvement. So some of you might notice that it takes, multiple seconds for this to run end to end. Quicksilver is going to be a pretty massive performance improvement and reduction of communication between the prover and verifier. There's still lots of work to do, and this is one of them. And yeah, we'll be posting some benchmarks with that release. They should be pretty nice. Yeah, going into next year, there's a couple nice to haves. Just TLS 1.3 support. TLSNotary right now only supports 1.2. For most people, that doesn't mean anything, but TLS 1.3 is kind of like the most recent version of TLS, and 1.2 in the future may get deprecated, so we want to be ahead of that. But yeah, the theme for 2025 is going to be towards stabilization. We kind of want to finish, if that's possible, the core library, the core implementation, work to get the underlying MPC library audited, and then start working up into the TLSNotary stack and get different parts of the code base audited. We're going to be working on security proofs for the for the various different cryptographic instructions in our protocol. Proofs already actually kind of exist. Paddle Labs with their garbled and proof paper actually covered a lot of what we're doing, but we kind of want to replicate those results ourselves and present them. So yeah, 2025 is going to be, well, of course, after shipping the performance improvements of Quicksilver, it's going to just be like, let's try to stop changing things as much and just kind of focus on getting it towards stabilization so we can remove the for research purposes only disclaimer on the repository, which is on like 99% of crypto projects. Yeah, so any just Q&A on future of TLSNotary? Other than when Quicksilver and when Opticode? Raise your hand.
Is your server fully trustless, just possible, or do we have to have our own servers on production?
By server, you're referring to Notary? So the question is our Notary fully trustless? So it depends on what exactly you're talking about there. So a notary is going to be issuing an attestation to the data, right? So the prover's connecting to the notary, they're proving information to the notary is putting a signature on it and saying, I ran this protocol correctly. Now, the prover takes that attestation and presents it to another party. There is a trust assumption there. That third-party verifier is essentially trusting that the notary ran this protocol correctly and that they didn't just forge this attestation without doing anything. So in that sense, there's trust. But is there trust between the prover and the notary itself? No. There's nothing that the notary, a malicious notary, can do in order to, like, for example, leak the user's secrets. They don't really see anything. They're just signing kind of like blind commitments to the data itself. So from a privacy perspective, no, there's no trust assumption. Now, a lot of off-chain applications don't actually need a notary. A notary is really only needed if you want to, like, maximum privacy. This party doesn't know anything, and it's just attesting to data that it doesn't see. You could actually just remove that step, and the prover can just selectively disclose directly to a verifier that's willing to run the TLSNotary protocol. And in that sense, like, the whole protocol end to end and the integrity of the data is, like, quote unquote trustless. Like I mentioned in the introduction, the protocol is designated verifier, so a lot of people want to build applications on chain, and in that configuration, you're kind of just stuck with this trusted third-party attestation. So, like, in short, it depends. But in terms of security for the user, we worked hard to make sure that, no, there's no trust assumption there. It's cryptographic assurances for the privacy of the data.
What about if I want to connect with the Oracle to make sure that it becomes trustless? Like, how can you describe how it's going to be like?
Can you repeat the question? Perhaps, okay, maybe I'll try to rephrase this. Can you construct, or how do you, I guess, minimize trust if using TLSNotary to construct an Oracle protocol? Yeah, that's a good question. There's a few different folks that are looking into this. One of the issues is that, again, the protocol is designated verifier. So you can't have multiple parties attesting to the same connection. So a prover will need to prove to, I guess, each Oracle node independently, and then they'll all have to come to consensus on some fact that the prover is trying to prove, as opposed to all essentially just providing a signature on a single transcript. There's a subtlety there in that every time that you query the server, the transcript is gonna be slightly different somehow. There'll be some sort of entropy in it. So the question of how to, like, construct a trust minimized Oracle protocol is difficult. The ideal solution is to make TLSNotary support multiple notaries in the MPC TLS protocol. The issue with that is that there aren't really any MPC protocols that exist in which that would be practical. The compute and the bandwidth costs of the protocol just, like, blow up if you try to add additional parties. So we're kind of stuck with this two-party setting. So yeah, trust minimization is really just going to come down to, can you construct a clever consensus protocol with multiple notaries? And you're really just getting into, like, Oracle design and things like that. We're kind of punting that problem to people that are focused on Oracle protocols, whereas TLSNotary is kind of just a primitive that you can use to construct it. But yeah, it's an active area of research for many people, is how to take these zk-TLS libraries and do that, and it's tricky.
More questions? So feel free to finish the workshop later at your own pace. If you run into any problems, just ask your questions on our Discord. There's only friendly people there willing to help. And how do we switch to it?
You just scan it, you can just, you register as a question asker, you can see the questions.
Okay, we're figuring out how to get to the questions in the Devcon tool.
How's it compared with other TLS protocols like Deco, Reclaim, etc.? In subtle ways, they're all essentially trying to achieve the same thing, which is how do you modify TLS in order to get a protocol that proves integrity of data from some source. So Deco, I believe the original paper actually described both the MPC approach and the proxy approach. I'm not sure where they're at with implementation. I think that they have a proof of concept or at least like a sandboxed early release that they just put out, but I need to kind of follow up and see what they're doing. In terms of implementation, yeah, I believe that Deco is doing the MPC TLS approach as well, but that might be outdated information. Reclaim is also essentially doing the same thing as TLS, but they're taking like this proxy mode approach. There are privacy and security kind of trade-offs to consider there. It would probably take me a full presentation, a full 30, maybe 45 minutes to go into all those differences. But in terms of affordances, they're all essentially trying to do the same thing with various different performance and privacy trade-offs. That's kind of a dodge of an answer, but that's the best I can do right now. All right, I think we can wrap it up. Thanks for coming, everyone.